Welcome to Edgecore Enterprise Switches training program. Hello, everyone. We are so glad that you could join us for online training today. This video will introduce the Edgecore Enterprise Switch interface commands. We hope you can learn the interface commands and how to use them in this course. We have divided the following sections to help you understand interface commands and how to use them in Edgecore Enterprise Switches. First, we'll introduce the physical interface types and how to configure them. Second, we'll talk about interface status, which covers how to administratively enable or disable a port, and how to check the link speed in duplex. Third, we'll talk about interface counters, which show how Edgecore Enterprise Switches keep various counters regarding the traffic that passes through them, and how many errors have occurred. We'll show you how to find and analyze these interface statistics, and what kind of interface errors there are. Finally, we'll talk about the transceiver status and configuration. After watching this training video, you can follow the procedure and command to test in your lab or network environment. If you have any questions or feedback, please feel free to contact us anytime. Let's get started. We use Edgecore ECS415028P switch as an example. ECS415028P is equipped with 24 RJ45 gigabits Ethernet ports and 410G SFP plus ports. For the RJ45 interfaces, we can simply connect a computer with UTP cable. We don't have to configure anything manually. When we want to use the 10G SFP plus ports, we'll need transceivers and fiber cables. You can find the transceiver and switch compatible list on the Edgecore website. In this section, you will learn how to check the interface status of different types of ports on the switch. These include RJ45, SFP, SFP+, QSFP+, and combination ports. The interface status can tell you whether the port is connected or not, and what speed it is operating at. This can help you troubleshoot and resolve issues. Ethernet auto-negotiation is a critical feature in modern networking that allows devices to communicate with each other using the highest possible speed and duplex mode that they both support. This can improve the performance and efficiency of the network. On Edgecore Enterprise Switch, all ports support auto-negotiation by default. Some of the benefits of auto-negotiation are: 1. Plug and play. Auto-negotiation can automatically detect and adjust the settings according to the capabilities of the connected devices, without the need for manual configuration. 2. Optimal performance. It ensures that devices use the fastest and most efficient network settings, enhancing network performance. 3. Reduced errors. It helps to avoid duplex mismatch, which is a common cause of network problems. Duplex mismatch occurs when two devices use different duplex modes, such as one using full duplex and the other using half duplex. This can result in collisions, errors, and reduced throughput. Auto-negotiation can prevent this by ensuring that both devices use the same duplex mode. 4. Backward compatibility. For example, auto-negotiation can enable a gigabit Ethernet device to communicate with a fast Ethernet device by downgrading the speed to 100 megabits per second. The Show Interface Status command displays the status for an interface. If no interface is specified, information on all interfaces is displayed. The interface status is divided into 3 sections, including basic information, configuration, and current status. In this example, in the basic information section, we can see that the port type is 1000 base SFP. If the port is an RJ45 connector, it will show 1000 base T. Some of the settings that we make based on the switch function will be displayed in the configuration area, such as storm control related settings, or enable-disable port settings. In the current status area, we can see the current status of the port, such as link up or link down, and the current link speed and duplex. Next, we will examine a useful command that shows a summary of all interfaces on the switch. Use Show Interfaces Brief command to get a summary of key information. The first field is Interface ID, We can see there are 28 ports on this switch. The second field is name. The default setting is blank. We can use description command to add a description to an interface. The third field is status. We can see that only port 22 is link up. Next is PVID. PVID means native VLAN ID. It is VLAN 1 by default. The next field is priority. The default priority is 0. Speed and duplex are all auto-negotiation by default. If the port is link up, it will display the link speed in duplex. The port type fields show that from port 1 to port 20 are SFP interfaces, and port 21 to 24 are RJ45 interfaces, and port 25 to 28 are 10G base SFP plus ports. Lastly, the trunk field display none. That's because we haven't configured any ports to port channel. If we add port to port channel group, we'll see the group ID in this field. Some Edgecore switch models support combination ports, also known as combo ports. The RJ45 port and SFP port share the same port number, so we can only use one of them for connection. Some of the benefits of combo ports are versatility. You can use combo ports to connect various devices with different connection types, such as computers, servers, and other switches. Cost efficiency. You can save money and space by using combo ports instead of buying separate switches for copper and fiber connections. Scalability. You can easily expand and adapt your network by using the same switch for different connection types with combo ports. The ECS412028F has 4 combo ports that you can use for either copper or fiber connections. These are ports 21 to 24. The default setting for the combo ports is SFP Preferred Auto. This means that if you connect both RJ45 and SFP ports at the same time, the switch will use the SFP port as the higher priority. You can use the media type command to change this setting if you want. The following examples show the status of 2 combo ports on the switch. On port 21, we plug in a transceiver and use the command show interface status Ethernet to check the status. We can see that the port type is 1000 base SFP, the capability is 1000 full only, and the operation speed and duplex are 1000 full. On port 22, we plug in a UTP cable. The port type is 1000 base T. The capability includes 10 half, 10 full, 100 half, 100 full, and 1000 full. The operation speed and duplex are 1000 full. The Edgecore ECS55 2018X has 2 40G ports, port 17 and port 18, that support breakout mode. You can split each 40G port into 4 10G ports using a breakout cable. Breakout mode is a feature that allows you to divide a high-speed Ethernet port into multiple lower-speed ports. For example, you can use breakout mode to connect a 40G port on a switch to 4 10G ports on different devices. This way, you can use the full bandwidth of the 40G port and connect more devices to the network. Breakout mode is often used in data centers and high-performance computing environments to make the most of high-speed connections and optimize network infrastructure. In this example, we break out port 17 to 4 10G ports by using the command hardware profile port mode Ethernet 1/17 4x10G. After changing the hardware profile port mode setting, we need to reboot the switch. After the system reboots, port 17 breaks out to 4 10G ports of ports 19 to 22. The Ethernet switch interface counters are a set of statistics that show the status and performance of each port on the switch. They can help you troubleshoot network problems, monitor traffic patterns, and optimize network efficiency. In this section, we'll introduce some of the common interface counters. The Edgecore Enterprise Switch interface statistics include the following data: number of packets received and sent. This shows how many packets have been transmitted and received by the port. Number of input and output errors. This shows how many errors have occurred on the port during transmission and reception of data. Errors can be caused by various factors, such as faulty cables, connectors, devices, or interference. Number of CRC errors. This shows how many packets have been received with a faulty cyclic redundancy check value. A CRC is a method of detecting errors in data transmission by comparing a calculated value with a value stored in the packet. The port utilization gives more analysis of the port performance, such as transmitting, receiving rate, and utilization. We used the Show Interfaces Counters command to check the statistics on port 1. The interface table statistic shows the basic statistic about the input and output of unicast packets and error packets. The extended interface table statistic shows more detailed information about the transmitted and received of multicast and broadcast packets. The Ether-like statistic shows the statistics per port according to the Ether-like MIB standard definition. It can help you monitor and troubleshoot the physical layer errors that might disrupt the network traffic, such as FCS error, symbol errors, collisions, etc. RMON statistics are based on the RMON MIB standard definition. It can help you monitor and troubleshoot network problems. The RMON statistics displays detailed information regarding packet sizes and information regarding physical layer errors. The difference between the port utilization and statistics is that the interface statistic gives a general overview of the port activity, while the port utilization gives a more analysis of the port performance. This is an example of port 22. The counters are split into 5 sections that we have discussed in the previous slides. The input and output counter have increased, but there are no errors. The statistics will be initialized by a power reset. We can use the clear counter command to clear statistics on an interface. Transceiver is a device that can convert electrical signals into light signals that can travel through a fiber optic cable, and vice versa. It allows two devices to communicate with each other over long distances using fiber optic cables. In this section, we'll introduce several types of transceivers and how to manage them. UTP, or unshielded twisted pair cable, is a high-quality and affordable option for connecting your computer to a switch with a Cat5e cable, which is the standard wiring in most homes and offices. However, UTP cables have a maximum length of 100 meters. For longer distances or buildings without dedicated wiring, fiber optic cable is a good choice instead. Edgecore Ethernet Switch provides several models of switches with SFP and SFP Plus ports to satisfy your long-distance wiring requirement. In this example, we use ET5402LR transceiver, which works on 1310 nanometers wavelength. Over single mode, LC fiber cable reaches up to 10 kilometers. There are different types of transceivers and fiber cables that have different characteristics, such as wavelength, speed, distance, and connector. The SFP and SFP Plus are two types of most frequently used transceivers on enterprise switches. In this table, we can see the key difference between SFP and SFP Plus is the data rate. Both form factors are either RJ45 or LC connectors, support single mode, multi-mode, or copper media types. This table shows different types of SFP1G transceivers that have various features. The features include the connector type, the wavelength, the transmission medium, the distance, and the power dissipation. The table compares how these features vary across different transceiver types. This table shows different types of SFP plus 10G transceivers that have various features. The features include the connector type, the wavelength, the transmission medium, the distance, and the power dissipation. You can find these tables at the Edgecore website. 25G Ethernet has become more popular recently because that provides 2.5 times the bandwidth of 10G Ethernet with a small incremental cost. This table compares two models of SFP28 transceivers that can be used for 25G connections. This table shows two types of QSFP Plus transceivers that support up to 40 gigabits per second. Use the Show Interface Transceiver command. We can get the details of the specified transceiver, such as the connector type and the vendor-related parameters. It also shows the current values of the temperature, voltage, bias current, transmit power, and receive power. The DDM thresholds specify the values that trigger an alarm or a warning message when the parameters fall outside of specified thresholds. These values help administrators to remotely troubleshoot problems with optical devices. You will see a message that says DDM not supported if the transceiver does not support DDM. DDM refers to Digital Diagnostics Monitoring. It is a feature that lets you check the real-time status of your optical transceiver modules. It can tell you things like temperature, supply voltage, laser bias current, laser power, and received optical power. This can help you to troubleshoot problems, predict failures, and improve performance. In this section, we'll introduce how to use DDM information to manage our transceivers. The interface itself is capable of generating alarms and warning flags, which alert the switch when operation parameter falls below or rise above the specific transceiver's manufacturer thresholds. This allows the system administrator to isolate faults and predict failure. By default, the switch uses threshold settings obtained from the transceiver to determine when an alarm or warning message should be sent. If we want to manually change any threshold, we should use the No Transceiver Threshold Auto command to disable it. Then we can change the threshold value. In this example, we set the temperature thresholds for high warning and high alarm to 51 degrees Celsius and 52 degrees Celsius respectively. The transceiver monitor command sends a trap when any of the transceiver's operational values fall outside of specified thresholds. The default setting is disable. Let's enable is by typing transceiver monitor. We use Show Interface Transceiver Threshold command to display port 25 and port 26 DDM information. You can see the transceiver monitor is enabled, and the transceiver threshold auto parameter is disabled on port 25. The temperature high warning and high alarm have been changed to 51 degrees Celsius and 52 degrees Celsius respectively. The port 26 keeps the default setting without any changes. Here is an example. Suppose the transceiver on port 25 has a receive power of -40 dBm, which is below the low alarm threshold. In this case, a RX power low alarm trap will be sent out. If the transceiver's temperature exceeds the warning threshold, a temperature high warning trap will be sent out. If the temperature continues to rise and surpasses the alarm threshold, a temperature high alarm trap will also be sent out. In addition, syslog messages will be sent to notify the system administrator. In this unit, we have learned about the various types of Ethernet switch interfaces, such as 1000 base T, 1 GSFP, 10 GSFP+, 25 GSFP28, and 40 GQSFP+, which differ in their speeds, distances, and connectors. We have also learned how to check the different statuses of the Ethernet switch interface, such as link up, link down, administratively down, etc., which indicate the physical and logical states of the port. Moreover, we have learned how to use the different statistics of the Ethernet switch interface, such as packets, bytes, errors, collisions, etc., which can help us monitor and troubleshoot network issues. We hope this course has helped you to manage and troubleshoot the Ethernet switch port effectively. Thank you for your participation, and we hope to see you in the next unit. If you have any questions, please feel free to contact us anytime.